So we begin our unit on polygons. One of the things that we can do is we know that all triangles add up to, the interior angles of a triangle add up to 180. And we recently talked about that the interior angles of a quadrilateral add up to 360. And that's because a quadrilateral has two triangles contained in it. So we're going to extend that and find out what the angles of any polygon is. So I've got several polygons here, and we're going to draw first the diagonal. So diagonal means we're going to go from one corner across to another corner. So you can't draw a diagonal here because that would be on the side itself. And then we would draw across here. So this is a five-sided figure. Its name is a pentagon. It has 5 sides. When you draw in the diagonals from one vertex across to all available other vertices, you end up with 1, 2, 3 triangles. So there are 3 triangles. Okay. The sum of the angles of each of these triangles is 180. Well, 180 times 3 is 540. So the sum of the interior angles of every pentagon is 540. We can continue that. So a hexagon, this is a hexagon, it has 6 sides. If I draw from one vertex across to every other available vertex, I end up with 1, 2, 3, 4 triangles. If I take each of those triangles that total 180, that gives me 4 times 180, which is 720. A heptagon has 7 sides. Heptagon is 7. So if you draw those in, you get 1, 2, 3, 4 diagonals. So you have 1, 2, 3, 4, 5 triangles. And each of those triangles has 180 degrees. So 5 times 180 is 900. So the interior angles, and by interior angles, what I am talking about is the angle at each vertex. So I'm talking about those 5 angles. Each of those angles at each vertex would add up to that total. An octagon has 8 sides. If you draw in all of them from one vertex across to all other available vertices, you end up with 6 triangles. Hopefully you're starting to see a pattern, times 180, and you get 1080. So in an octagon, all 8 angles would add up to 1080. A nonagon has 9 sides. You will need to know the names of these and the number of sides that they have. This is a nonagon. So if we continue, 5 had 3, 6 had 4, 7 had 5, 8 had 6. That means 9 will have 7. Each of those 7 triangles has 180 degrees. So the sum of the interior angles of a nonagon is 1260. A decagon has 10 sides, which means it has 8 triangles. Each of those times 180 is 1440. An undecagon is an 11-sided figure, which means it has 9 triangles, which would be 1620 degrees interior angles. A dodecagon would be a 12-sided figure. 12-sided figure has 10, and times 180 would be 1800. So a 12-sided figure would add up to 100, would be 1800 degrees. So an n-gon, anything class 12 is just called an n-gon. You can have a 13-gon, a 15-gon, a 20-gon, whatever it is. Okay, so an n-gon has n number of sides, so a 23-gon has 23 sides. So if it has n sides, that means it has n minus 2 triangles. So there are 2 fewer triangles than there are sides. So to calculate the sum of our interior angle would be 180 times the number of triangles. Okay, so don't memorize the formula. There it is. It says that the polygon interior angle sum theorem says that it is n minus 2 times 180, or 180 times n minus 2, where n minus 2, n is the number of sides that it has, and n minus 2 is the number of triangles. Okay, so you just want to think about that pattern of the number of sides minus 2 is the number of triangles. Multiply that by 180, and you don't have to memorize the formula. You just have to recognize the pattern, that there are always 2 fewer triangles than there are sides. So the question might say, a regular convex polygon, regular means all the sides are equal to each other, has 13 sides. What is the sum of the interior angles? So if there are 13 sides, then that means there are 13 minus 2, there are 11 triangles. If there are 11 triangles times 180 degrees in each triangle, so 11 times 180 is 1,980. So the interior angle sum is 1,980. Then it says, what is the measure of each? Now this is important because I called it regular. Because it's regular, what I know is that all of the sides are equal to each other and all of the angles are equal to each other. Since all of these angles are equal to each other, I can take that 1,980 and divide it by the 13 angles in the shape. If there are 13 sides, then there are 13 angles. So 1,980 divided by 13 is, each angle is approximately 152.3 degrees. You can only do that with regular figures. If it's not regular, then you can't calculate how much each of them is individually, where they're all the same size. Okay? The sum of the interior angles of a polygon is 2880. Find the number of sides. There are several ways you can think through this. You can just process it. Well, if the sum of the interior angles is 2880, now let's do this algebraically. Okay, if you memorize n minus 2, the number of triangles, times 180, then you get 2,880. So however many sides there were, minus 2, give me the triangles, times 180. So if we take this, we can divide both sides by 180, so 2880 divided by 180 gives me 16. Now remember, that is 16 triangles. Okay, there are 16 triangles because I divided them into 180-degree increments. If I add 2, then that will give me 18 sides. Okay, so the interior angle sum is found by calculating the number of triangles, which is 2 fewer than the number of sides, and multiplying them by 180 because the interior angle sum of a triangle is 180. Now what about the exterior angles? Exterior angles, if you extend the sides of the shape in one direction, then these are your exterior angles. So you have one exterior angle at each that you would consider. You would have one exterior angle at each vertex. Well, let's kind of do a little bit of discovery here. So these are linear pairs. If you take 180 minus 79, you find out that this angle is 101. 180 minus 61 is 119. And 180 minus 40 is 140. Now the sum of the exterior angles this time, those exterior angles, the sum of the interior is 180. The sum of the exterior would be 119 plus 101 plus 140, and you get 360. So that's interesting. I wonder if that always happens. If you go over here and you find out what each of these exterior angles is, so let me take a second and find each of these. So presuming that I did all of those right, they're all linear pairs. The interior plus the exterior is equal to 180. We might make a note of that. We might need that later. Interior plus exterior angle is equal to 180. They are a linear pair. If you add all of those up, 63, 65, 51, 56, 68, and 57, if you add all of those up, you do indeed get 360. So that is not coincidence. The sum of the interior angles changes. Notice that the sum of the interior gets bigger as you increase the number of sides, but the sum of the exterior is always 360. It never changes. It is always the same regardless of the number of sides. The sum of the exterior angles is 360 degrees for every shape. The sum of the interior changes. So find the sum of the measures of the exterior angles, one at each vertex, of a regular 24gon. What is the measure of each exterior angle? So the sum of the exterior, that's always 360. Always. Okay? Now what is each? Each, we would take that 360 and divide it by 24 sides. 360 divided by 24 is 15. So there are 15 degrees at each of those exterior angles. Now keep in mind, you could also find the interior from that. So the fact that the exterior stays consistent and constant also helps us to find the interior and might make it easier for us to find the interior angle sometimes. Number 4 says to find the measure of each exterior angle of a regular hexagon. What is the interior angle? Each exterior, so all exteriors, right? All exterior is equal to 360. Well, if this is a regular hexagon, that means they're all the same size. So you can take 360 and divide by 6 and find out that each regular angle is 60 degrees. That means that each of these angles out here is 60 degrees. Remember that the interior and the exterior are a linear pair. So 180 minus 60 is equal to 120 degrees. So that interior angle is equal to 120 degrees. Now you could also find that interior angle by finding the sum of the interior angles, right? There are 4 triangles in there times 180. You would get 720 divided by 6 is 120. Okay? So let's look at some practice problems. Find the sum of the interior angles and the sum of the exterior angles of a nonagon. That means you have to know what a nonagon is. A nonagon has 9 sides. That's often the hard one to remember. Find the sum of the interior. Sum of the interior always changes. The sum of the interior is the number of sides minus 2. So there are 7 triangles times 180. 7 times 180 is 1,260. So the sum of the interior angles is 1,260. The sum of the exterior angles, always 360. Always. Never changes. Okay? Now, the measure of the exterior angle of a regular polygon is 72 degrees. Find the number of sides of the polygon. Well, each exterior and exterior angle, well, all exterior is 360. So if I take that 360 and divide it into 72 degree pieces, then I have 5 exterior angles, which means I have 5 sides. So knowing that exterior angle, over here, if we go back, you can find the number of sides, so you can kind of use that same idea, but the exterior, actually with this one, this algebra way is the easiest way to do it. But over here, you wouldn't want to do that. You would want to, you could find the interior angle, but you still have to find the number of sides. And so you could find that interior angle and set it equal to n minus 2 times 180 divided by n. But always that exterior angle is always the same. Now with these algebra problems, they're going to work the same. Now the thing is though, we've done these with triangles, right? Where we had say 2x, 3x, 4x minus 5, whatever it was. And we knew, set those equal to, add them up, combine like terms, and set them equal to 180. Well, we can do the exact same thing, only now this doesn't add up to 180. This adds up to 1, 2, 3, 4, 5. So 3 times 180 is 540. So you have to either memorize that or know how to add that up. So now you would do 5x plus 2. You would take each of these angles individually and add them up. So 5 plus 5 plus 4 plus 8 plus 3 is 25. So we have 25x plus 2 plus 10 plus 15 plus 8 plus 5 is 40 is equal to 540. If you collect your like terms, subtract 540 minus 40, and then divide that by 25, you'll find out that x is 20. But the trick is recognizing, this is the hardest part, is recognizing that you have to figure that out. This is a hexagon. There are 6 sides. A hexagon adds up to 720. Okay, 4 times 180 is 720. After a while, you memorize them. So if you add them up, we have 1, 2, 3, 4, 28 plus 8. We have 36x is equal to 720. And that gives us that x is equal to 20. X is equal to 20. Okay. Find the measure of each interior and each exterior angle of a regular, that matters, octagon. Octagons have 8 sides. To find each, now you can choose how you want to do this. You can find all interior and divide by 8, or you can find all exterior, which you don't have to find, and then find your interior from there. So you can decide, like whatever comes naturally. You can find the sum of the interior and divide by 8, or you can use the sum of the exterior, so 360 divided by 8 is 45. So each exterior is 45 degrees. Well, if each exterior is 45 degrees, 180 minus 45 is 135. Each interior is 135. Now, say you didn't see that. Then you could say 8, well that's 6. 6 times 180 is 1080. So I have 1080 degrees to split between the 8 angles, and you get 135. So you'll get that either way. But I like to use exterior whenever possible because the sum of the exterior doesn't change. Now, the measure of an interior angle of a regular polygon is 156. Find the number of sides of the polygon. So we're back to finding the number of sides, but this time we have one angle. We have an interior angle. Now again, the problem with the interior angles is the sum of the interior angles changes. However, the sum of the exterior angles doesn't. So if we use that idea that the interior and the exterior is a linear pair and take 180 and subtract 156, we get 24. That is each exterior angle. Well, how many exteriors can I fit into 360 degrees? I have 24 degrees for each exterior angle, so if I take my 360 degrees and divide it into 24 degree increments, I find out that I have 15 sides. Okay, so whenever possible, using those exterior sums makes it so much easier because the exterior doesn't change, but the interior does.